very much. It's a bit delayed today. I'm sorry for it. We apologize for the delay, but I think we'll make it up slightly. I welcome you all, and I will hand over to Dr. Indramani to welcome all of them for 2.0.
I welcome all the friends, particularly Dr. Baruah, today's speaker. Baruah, great welcome. Nice.
Thank you, sir.
In this Asmij Gamcha.
Thank you, sir.
Wonderful. Thank you. And I welcome Professor Singh and all the friends. Friends, you know that we completed our webinar 1. That also started on 20th and of April, and on 20th of May we are again here together, and we have seen that webinar 1 was accepted very well from different age group professionals, including students to very senior people, peer group, and we got in fact energy from their comments and their observations that we should start webinar series 2 also. The idea behind the webinar series 2, when we discussed initially, to bring different category people, means industry, management people, bringing them to education institution, to research institution, and taking people from there and working out that how the problems, how we can take up the problems, and then idea was that this series will be finding out solution to existing problems, raising the level of people, their skill, their knowledge, and ultimately jointly, trying to lead to solution. And I want to emphasize that one of the objectives of this exercise will be to produce entrepreneurs, because the present situation, you know very well that during this COVID situation and post-COVID situation, we will need not job seekers, we will need job provider, if you see the current situation. And the present startup ambience and entrepreneurship development ambience is very good in the country. It was started, much in advance. And if you remember that even Ministry of Agriculture and Farmers Welfare have started a very good program under ARISE, and all different institutions are working together and to develop entrepreneurship through startup mechanism. So, and we are engaged in those activities, Dr. Syed, and we are finding that many of these startups who are trying to take up the project in agriculture side are lacking skill, commitment, and all kind of, the requirements which entrepreneurs should have. So probably this exercise, we will try to connect them also and see that how their skill also can be improved. And finally, this would lead to a solution mart, which we have been talking. Friends, this is again, let me tell you, era of engineers and particularly bioengineers, because all the problems which civilization is facing today, there are 4 major types of problems. I have mentioned these earlier also, and those are related to food, related to energy, related to water, related to climate change, and now this kind of virus and other situations have been added. I'm very much confident that bioengineers and agriculture engineers can be made capable to find out solutions of all kinds. I will be very interesting story. Just I will tell that one project was given, under IIT Kanpur, and under that is hub and spoke mode, and three spokes. If I want to tell you, one is agriculture, that IARI, other is HBTI, and third one is BGI Lucknow. So see that medical people, craft people, and then uh, this textile people all coming together under one umbrella of engineers and finding out the solution. We have been discussing during the preparation that we will be taking up, like this is a slogan nowadays, health for all. So health for all means health of soil, health of plant, health of animal, and coming to health of man. So how engineering is going to bring make intervention and bring solutions, that also we will see, and we have to raise our level that in all these activities, in all these pursuits, we can participate. I'm having a lot of hope from this series of webinar, and frankly telling that we had basically some problem from last 2-3 days to start it, and I'm really sorry that Sayyid, that certain things have been to convert into and to start it, there has been problem, but we will overcome. Let me tell you, there's another very good thing has come up. So people working in academia and people working in industry, they are in different ambience. And now with this webinar, we are trying to learn from one another how we can go for, because and what all you are facing, this is that inertia, that kind of things. We work under one ecosystem, and the industry people work under another ecosystem. How we can learn from one ecosystem to other system. This webinar preparation, I'm telling you, not stop leave webinar series. I'm just telling you that the preparation level we are learning a lot. So overall, this is going to develop skill of the agri engineering professionals in different arenas, and are very hopeful and very means what we can say sanguine to success of this webinar series. And we have our very personal friend today, Dr. Baruah, who will be who is the opening batsman of webinar series 2. And once again, I really thank from core of my heart my friend Dr. Sayyid. Much had to be discussed, and the kind of problem and issues he has faced. I take all the responsibilities as president of ISAE, and we will ensure that in future this kind of problems does not arise, and we run a very smooth webinar series. But friends, you know that if you don't face problem, you don't become mature. So let us consider this. Whatever problems my younger friends have faced in making preparation of this webinar, this will make you stronger and stronger, and you will learn all these activities. With this, I request Dr. Sayyid to start the rest of the program. Dr. Sayyid, please. So
yeah, I'm there.
Okay.
Thank you very much. Thank you very much, Dr. Indramani. Actually, it was a small issues, but I think it will be sorted out. So that is not a big problem. I will tell you how the webinar 1.0 started. Is from what I have seen is most of the universities or research institutions, they don't know much about technology who are working in agriculture. That's how it started. So it went on well. So we combined it, actually a little bit of training we are given on basic electronics, basic embedded systems, how it looks like, and what are the communication, what are the sensors. This was people who are first basic electronics, and people were not very happy because that's very deep subjects. But then when it comes to sensors, a lot of people appreciate it, and what are the networking possibilities and how it is. So people were asking me afterwards about how really we will learn all these things. So the problem started there is to conduct training in basic electronics and making everybody electronic engineers in one way. Another way is to see that work, how it can be done when you distribute the work together. So the Webinar 2 has a series of functions now. Very simple is to keep the same motto of automation in agriculture. That is not changed. So we don't want to make this forum as to just talk any topic, any excellent topics in agriculture. There are so many topics in agriculture. Something like making a pond, well, also for irrigation in for example, in climate excellent agriculture, excellent topics we have. But we will limit to some involvement in technology in all this application, because that is the USP of this particular webinar we are conducting. So we have a team called TAG team, that is Technology Application Group. We are in the process of formation. We have a few members, couple of maybe 12 members we have now. We want to make it a large group, and this group will be responsible for finding solutions, technological solutions for them. So first we'll train this group, and they will in turn train the rest of the people. This is the idea. So we take a topic, for example, we give a speaker or whatever it is, a research work which is being done right now, or a work which is already in the project level, or probably we take a work, an idea only. Somebody comes with an idea, this idea is excellent, we want a technology in this to be involved. No problem, we give time for them to explain that ideas also, okay. But if you've done a project, your need of technology, we are first one, we take priority for you. So we'll listen to you, and we'll try to find out a solution of technology program faster for you. There are many components of technology, we try to help you out. So today is an exercise, we will see that also. So I would request all of you to cooperate, because technology is something area has been neglected in agriculture engineering till now. For example, thousands of people talk about drone, but actually no agriculture engineering work in drone has been done according to me. We'll come back to the next topic, I'll explain why. The fruitful thing, like the money we invest and how much returns the farmers are giving. Whereas we need some areas, we can use it, but the concentration has gone a difference. We'll come to the technology, how to use it. In many areas we are using. So I think the tag group is one of the important things. What do you think? That we listen to the people, research work what is done, we coordinate, find the problems, find a solution. Plus, we have another wing which will train these people also. And plus, one more thing I found is not only technology, we require other skills which are not with agriculture engineers to learn the technology how to come up. For example, presentation skills, some people don't have. We talked about some communication skills, maybe some small topics, interesting management. Nobody knows about management skills that much, because I know that, because now the agriculture is going to be open now. What announcement has come, the sector is going to be really a revolution in agriculture has come, especially when the whole market will change, money system will change. When you have of course, I hope it will be done in the parliament, but the idea is very good. And one more thing, we have also spatial data available now for the private party. This will really open up a lot of work in technology for agriculture. Like every piece of land can be really found out, whether a particular project which government is doing for a development project of digging a well or something can be easily identified completely throughout the country. So I think with this, now I give the second part of this webinar 2, the objective. One I told already, second one for training and everything. I want to request Robesh Mighty to explain that, please.
So good evening and good morning to all. So thanks, Dr. Indramani, Dr. Syed. So one of the things which Dr. Indramani said, it's the academia and the industry here. There are different ecosystems, and this is the system which is bringing them together. So I am coming from the industry with about a total of 37 years of experience, postgraduates in mechanical engineering from Indian Institute of Science, with 20 years in agricultural equipment, design and development, and that has been my forte, and I'm continuing to be working on the same. So that's how I bring the industry from my side. So as already said, we have worked in 1.0 and we are going to 2.0, but this time the learning is not theoretical. It's more of getting engaged, and it's the technical expert. So there's a lot of expertise available. There's a lot of work also going on. But ultimately, when we see the technology is not coming, when automation technology is not coming in the actual world, and that problem has been recognized, and that's how this technical application group is, and Dr. Sayed already explained a lot of things about it. So training will remain as a part of it. So it's both a technical part of it. So during the whole process of going through the webinar, so ideally that webinar, I would say, like Dr. Indramani was saying, it would have been a workshop, trying to say that some expert is defining the work which is there, and where he is getting, sort of an obstacle over there, and what type of technology intervention he needs. He does not. That is the time in front of technology application group. They have the field of experts. They understand the problem. They define the solutions and make it to the commercialization level. However, this probably the pandemic or the nature has taught us different methods, and maybe that is a most efficient method, and we are doing this Webinar 2.0. So in that, not only we'll be understanding the things from Dr. Baruah, who is there, and also we are trying to understand what are the different technology interventions are required. So it is learning by doing the actual working with it. So the help would come not only from the TAG, their expertise to bring the solution, but also I think if they don't have, we can always pull in the resources from or the expertise available globally, through the contact. And that brings a training to individuals as a TAG, but also to the other people. So during that process, we are also trying to identify the, what are the different expertise we have in a TAG. Of course, TAG is going to evolve, as we said that, and that is what we will utilize to understand the gaps and then try to see that that is imparted. So one more point, Dr. Sayed said that it's the not only the technical part of the training, associated with the technology. It's also to be, there is a softer skill requirements. The young engineers who are doing a very good work, probably they're not able to express their work in a certain manner, which is drawing the attention of the senior fraternities or the financial institutions. So I think those softer skills need also to be identified, and we believe that through our own expertise in industry and of course the research people, senior people in research, we will be able to, these skills are like something like presentation skills, your communication skills, or the project management or financial. So those are some of the things which we'll be looking at besides the technical training. What we also see is that, as Dr. Indramani said, I think nothing is today written in stone. The structure will be evolving. So as we do our first webinar, we probably will learn about it. And as we learn, we will probably stabilizing. I'm sure ISAE will mentor this whole tech group structure evolving and execution of the projects in the right manner. So that's the one where I would like to express. So thank you.
Thank you. Thank you. Thank you. Thank you, Rabesh, as a guy with industry experience. Come to the point. I think Dr. Indramani told, we industry, we make our own money. whereas the research, you're paid already for the work you're doing. So there's a big difference, very, very big difference. And we don't like no an answer. We don't take a no, we don't like excuses. And probably that's one thing I think we have to learn, because outside of India, the same like industry here also, outside of India, even the research is like that. They don't take a no for an answer, which can be done. Let us hope for it. Now let's come back today. It's excellent. First one topic. How we will do is we are going to have a presenter. He will explain a topic which is probably we all thought that is nothing to do with technology so much, but then the requirement of technology he will talk also. Then we will try to analyze very short time today, because the first day today we lost some time. But next meeting, we will come with a solution for that also. But first we'll discuss about solution also for that problem. So I think I'm very pleased to invite you, Dr. Baruah, and it's a very interesting. He is sitting somewhere in Assam, and I'm sitting in Mumbai, and I think like Indramani is sitting in Delhi. I think we are throughout the India people are we are sitting there. It's very happy. I'm very happy to welcome Dr. Baruah. It's yours.
Thank you. Thank you, and welcome. Good evening, Tezpur, in the Tezpur University. Here, I am first very briefly thank Indian Society of Agricultural Engineers and our organization. I do not know, I have heard both Rave's and side and their expectation, but I'm not sure whether these presentations, first presentations, as my friend in Romania said, and the first opening batsman that
You're having you're having voice problem.
Audio zero. But audio is not working. Hello.
Audio is not okay. Close.
Hello. Hello.
Yeah, now I can hear you.
Going.
Speak. You speak.
Okay.
Maybe now, can we request all the panelists also to unmute their video? They'll get a better bandwidth, and then we can hear the speaker. If those who are not speaking can just mute their video also, please. Yeah, I think that would be better.
Hello.
Yes, go ahead.
We can hear you now.
Am I audible? Yes, please. So this is I'm teaching last around 25 years, and then I'm a formationary man from IIT College of Technology and Agriculture Engineering, Udaipur, then trained at Kharagpur and Ludhiana. They got some flavor from for energy, and now I have interest in energy, mostly renewable energy, and I am doing some work or experiencing or learning the biogas system and biogas technology. Today's topic that will be mostly will be covered some of the issues on the biogas technology. The title is given just when the catchy title is needed. That's why it is given: Modernizing Biogas Technology, Scope for Promoting Farm-Based Circular Economy. But for the students particularly, I am a bit tempted to tell about circular economy. The circular economy mostly we say where there is a provision of recycle or your recover and then reduce. Those concepts are there. This is now being taken rather than a linear economy. For example, the crop residue, just give an example, crop residue is an economical material, or you could say economic resource, and if it is produced by involvement of the farmer economy, because there are many inputs are required, and then ultimately you are getting grain as well as your straw and other byproducts. If it is used by somehow, it is reused in the farming system, or there is an option that you can burn it or you can leave it there. There are two options. If it is burned or leave, then it is going to the environment and it is linear. If you bringing it back to the system for utilizations or making it as an economical commodity, then it's circular economy. That is a concept, I think, how biogas could be used, and is a better technology or better option for the circular economy that will be highlighted here. Next, please. Next, please.
Yeah.
Yes. So now mostly this will be covered here. That I will tell about some historical overview that is required to make this context of biogas as an important. It's important to be given by the historical overview, and then we'll see some scenario, world scenario as well as global scenario as well as Indian scenario, Indian context, and then what could be the probable benefits, how India is deriving from the biogas technology in terms of this government of India's different schemes, including the farmer incomes doubling, then sustainability issue, then circularity, and then lastly, maybe after giving this brief introductions, we'll go to directly the problem that we want to assert this technology, what technology is required, that gap, if any, that will be covered here. Next, please. If we see that historically, if you see that different technology that we are getting, It's said that this is, if I see the literature, this biogas, the concept is not a new. It is recorded that even 10th century BC or even 16th century BC, it was used mostly in the Middle East for the purpose of even saying that heating water or so. And then full record is available from 17th century, where it is from scientifically it is known that if some of the organic matter is allowed to decay, it will produce some gas, and then later on in around 1800 it is proven. And this I'm just telling you that this is methane known, but however, in context of a technology, that is biogas technology that we know as anaerobic digestion technology, AD, is 1859 was, as far as record is concerned, was first installed in Bombay. And then later it was also used for using fueling the street line systems in UK, England, in 1895. That it was moved, taken from this Bombay to that your England. And then later, its science was known. Science was known means it's a microbiological involvement. When this microbiology was developed, later 1930 or so, it's science, which are the useful microbiology, microbes, which works for better decomposition of the materials. Those things were known, and it becomes a scientific subject. One very interesting fact we should note that photovoltaic, which is now mostly a very established industry everywhere, and also one of the options of renewable energy, it's starting historical. Just I was looking for, just for my curiosity, it's 1839, but its industrial share is much more than this biogas technology. Biogas is more before than that. That we should understand that some driver, some is required, some boost up is required, something is required to make it popularize. The biogas, for example, as a renewable energy option, has more relevant, particularly the Indian context. I'm not saying photovoltaic is also required, but Indian context, farming context. But the way it would have been penetration, extension, I think something is missing. That will come later on. In India, the first, whatever from my own literature research, we found that Grihalak's MP biogas plant, it was recorded in Agriculture College Pune was first we found, 1951, and then Kadi and Village Industries Commission Planning Research Action Group there, Lucknow based in the year 1952, and finally we could see that government also in 1960 onward, next please, government has. And then there are the different program study of the government. It is taking care that it should be penetrated, it should be extended widely. However, of late, there's again renewed interest on this biogas. There are three specific reasons we could see from national context. One is that we are now really thinking about this energy security. Another is that intentionally, nationally determined our commitment, international commitment that we should go green, we should reduce this fossil fuel consumption. And our commitment is that 175 gigawatt installation of renewable energy by 2020, and out of that, 10 gigawatts should come from biosources. This is one of the reasons that biogas would be a very strong candidate in the renewable energy domain. Second is that we know this burning problem. Burning problem means not the burning problem, but really a burning crop residue problem, and that is creating a pollution issue, mostly in northern India, but any other parts also. And then crop residue, to make it a commercially viable commodity to use it for other options is not there. That's why it is burned there itself, and that is really an issue, headache for all, even it becomes a political issue too. Last one, this Swachh Bharat vision, that is total sanitation. It is realized that biogas could be in technological interventions to assist the Swachh Bharat visions by utilizing those waste, which is considered as a waste, into a resource. Biogas can bridge that gap from waste to resource. These three reasons I could see which are making this biogas technology again in the center stage. Next, please. Now, let us see energy security first. How is it possible? It's a myth or reality. If we see first that energy security, first we are considering biogas directly could be used as a cooking fuel, and mostly generally we use LPG as a cooking fuel, and we do not produce any LPG ourselves. We all are import, and import burden is really a burden for the government. And if we see the per month import, million tons of import is showing the per month 1.7, 1.8 million tons of oil, I mean, so bio or LPG we import. And this is a huge import. And this import, if you see, just I was looking through these Excel calculations, that per annum around 924 million gigajoule on an average of last few years. I took the data and just calculated that around 924 gigajoule of LPG energy, million gigajoule of energy, LPG energy we import per annum. And then just I was doing again Excel calculations, considering some of the inputs of our own research group here. And if whatever the agro residue produced in India, if we can take the surplus amount, I will show you the surplus amount in later slides. If surplus amount is used and then convert with this technology into this fuel gas to just substitute this LPG, is it sufficient? The figure shows yes, it is. It means that the ambitious plan of the government of India or even ours to make this our country independent of this LPG import is possible. And then biogas could be an prospective candidate for this. That is, energy security issue really could be solved or can be addressed if we have a strong candidate technology, sound technology of AD technology or anaerobic digestion or biogas technology. Next, please. Now, let us see how it is benefited. See, yes, this is, as earlier I told you, the crop burning problem, residue burning problem, and then how it is creating problem. And then some statistics says that the research findings, emissions, kilogram per hectare of emissions, particulate matter, PM10, then volatile organic carbon, NOx, SOx, CO, all are polluting agents, and their amount is given from some of the research in the national research only, and then kg per ton of straw burnt, kg per ton of straw burnt, this figure given, and this is alarming figure. This is one. And now another your map showing the different regions of India, and then we have assessed the crop residue, total available crop residue. We have estimated from the crop production data available in the Ministry of Food and Agriculture, share data, and then converted into residue by some factors, some research factors, and we found that around 600 million ton of crop residue is available. And even if we consider that 1/3 of it could be available as a surplus, because we could consider surplus is available, and then around 200 million ton will be available for energy purpose. Next, please. That means it is possible. How is this growth of this biogas technology? This is a global growth, we could say, just to understand the importance. Yes, growth in terms of numbers, there are increased millions in numbers biogas plant. I think this is a graph plot taken from some sources. I have not mentioned sources yet, but it is not mine, my research, but from other research. The number increasing. In India also, among them, this contribute. This is a global data, but Indian contribution is more compared to other countries. And then this is possible. This is achieved through the government initiatives. Number one, research and development efforts of different organizations, including universities, IITs, Indian Council of Agricultural Research, agricultural universities, and then obviously feedstocks are also available, abundance. These are the favorable conditions that promote the growth of the biogas technology. However, there is something missing, by which yet we are not able to convert this technology, a very popular technology, or very technology which could be easily taken by the people or the farmers where it is needed. There are still some gap. These missing things we will discuss today. Next, please. Next, please. Yes, just I will not read everything, but we should understand the initiative of the governments. There has been a continuous effort of the government of India, and I have listed the different schemes under the Department of Non-Conventional Energy Resources. It is now the Ministry of New and Renewable Energy. Earlier it was not ministry, it was department. They launched as early as 1960. And then 1980, there was a program, Integrated Rural Energy Program. It was launched in October 2, 1980. The National Biogas Development Program. It was also introduced, National Project on Biogas. And then 82 community institutions. And then night soil-based biogas plant. It is also introduced. And then claimed that around 3,900 plants were installed by 2020, 2002. And then 85 to 90 also, there are many schemes and where biogas is considered that it could, there are also support from subsidy support for training, support from service facilities, repair, monitoring and evaluations. There are many support by the government. Next please. And then in 90s also, if we see, there were some changes of this approaches. Along with this biogas, this manure, that means the digested slurry which remains out even after this production with biogas. Importance is seen here, and then this is being mostly that is out of this research, different research outputs showing that this is a very excellent fertilizer value on organic fertilizer. And then government schemes introduced that it is a manure management program, National Biogas and Manure Management Program. It was introduced in 2002. It continued even up to 12 5-year plan. And then of late also, there are different schemes. It is also shown that even a Ministry of Renewable Energy, it could be thermal, shown as a thermal energy program, application program, then new National Biogas and Organic Manure Program, and of late, there's a program called Galvanizing Organic Bio Agro Resources Done, that is Gobar Done. And this Gobar Done could address many benefits, including dependency on firewood for cooking, produce a byproduct called digestate, which helps in reducing the use of chemical fertilizer, improve sanitation in villages, reduce drudgery in indoor air pollution. Parallel to these government initiatives, there are different R&D organizations involved over here in India. I should mention the name of some of these very impact-making researchers of IIT Delhi, Professor Vijay's group, Indian Institute of Science, Bangalore, Professor Dr. Haisal Chanakya's group. Then we have, there are many, all agricultural universities, including PAU, Haryana, IRI, including NGOs, one very important NGOs, they are even have patented product now, BKNRD. There are many. And then research spreading, I should blame many. So I may not name all. And then out of this research, we could see there are different, many understandings, know-how is generated. And now here we could go ahead with this to take care of these present challenges of energy, sustainability, circularity, and giving more benefit, the required benefit for the farmer. Next, please. Now I'll show you some of these challenges. So here, if we see directly the benefits, it's a clean fuel, yes, because a section of the population is still, this is very recent photo that you could see some of the women folk along with the kids were carrying head load of fuel wood. This is not old photo, this is from my mobile and very recent 2018 photo in one of the villages. And this stove cooking, indoor air pollution loaded cooking is still there. A section of the population is still suffering like that. They have aspirations to cook like this, and that will have to bridge the gap. And biogas has really a strength to bridge this gap, because this biogas is dependent on their locally available resources, and it is known to them, and it is produced over here, and simple connections can make them, can enable them to cook clean, taking care of all those indoor air pollution issues, all those drudgery issues. This is a bit science for these students. I understand all agriculture engineering students know it, but still just to help them, the biomass is used, and there is a conversion process, it's called anaerobic digestion, and that there is a required process conditions so that microbiology bacteria could work on it, eat upon it, and produce this gas. And their requirement is that they need typical thermal conditions, temperature conditions, typical chemical conditions, pH, and then typical activity inside the digester, and that their productions become optimum, and ultimately we get the product, main product as biogas. And this biogas could help it. And this biogas contains a methane, Tezpur, and then carbon dioxide. Carbon dioxide is useless. Now, if we even have a technology, I'll discuss it later part, carbon dioxide could be scrubbed, reduced, then burning efficiency on the stove of the biogas could be increased manifold, and there is another benefit. Even if we do not remove and use it as such, both that is called biogas, methane and carbon dioxide, can be used to replace or substitute this type of cooking fuel. Next, please. Apart from along with this cooking fuel, next please. Along with the cooking fuel, it has a strength to address the fertility requirement or fertilizer requirement of these farming conditions. It is a advantage for the farmers as well, because these conditions that we use this crop residue or other manures, farm residues, through a conversion process, and then these microbes work on it. The microbes work, it produces the methane and carbon dioxide, and then some of these things remains undigested. Fortunately, they increase the value of the product, whatever its original residue. And then value, fertilizer value, nutritional value. Some of the non-available component of these nutrients become available now for the soil. That's how the value is added, number one. Number two, this can be reused for the farmer. And this has been found that by using it, we can reduce the dependency on these chemical fertilizers. And then these organic fertilizers, you're increasing the quota is already a requirement for India, because if you see the fertilizer applications on Indian farming and productions, we need more fertilizers. So now having these options of an uniformly for the country, we can reduce the dependency on this chemical fertilizer, which is non-renewable again, and thereby getting the double benefit by a single stone. Thank you. Next, please. Next, please. Shall I go to the next thing? I just am attempted to share some of our research. Here we could see that digested data says there are many research available, but this is a very recent research of one of my scholars, Dr. Sampriti Kataki. What was we tested this digested what remains? It is a solid component, it is a liquid component, and most is a neglected one. People do not give much importance. Mostly where there's a rural biogas plant, small scale biogas plant, gas is taken, but digested is left over here. We found that this digested can give benefit to the farm, having it a different fertilizer suitability index. We've seen different phases that and then we tested in crops. These are some test laboratory photographs I attempted to share with you. Another important point, I got this clue from this Indian Institute of Science, Bangalore. This liquid component of this digestate, which is mostly an headache because it creates a problem for this transportation of this digestate, handling of the digestate. Mostly in biogas plant, it is recirculated manipulum or bacteria, but small size plant, it is allowed to percolate to the ground. It is kept in a pit, unlined pit or ardent pit, or channel to this farm without having any lining. So it is a lost. If this liquid portion could be used for different purposes, here we tried it in mushroom production. And then mushroom production, we found it in some cases we found it's double the mushroom yield. Then there is some enzymatic and synergetic and biochemical effect of this the liquid portion of the digestate, which help it. That means the increasing the productions, the farmers' income, farmers' entrepreneurship could also be increased. That means it should not be wasted. It proved here. Next, please. Next, please. We have seen, and that I have already mentioned, how this is a neglected resource. We could see the photographs here is shown that this digested, here you see, it is either flown or kept on a pit, and this mostly is, there are different losses. One loss is that ammonia volatilizations. Some of the parts of the nitrogen is volatile, it lost. Second part is that in unlined or surface, it goes percolate deep and it no more available, and then at certain interval of time collected, much of the fertilizer goes down. And we tested it, we invested, and we found that through systematic study, we see important resource. However, to make it available resource or useful resource and commercial commodity, there must be some technological interventions requirement. That means we'll have to handle it properly, and we should have some provisions of technology so that this could be used as a resource. If this can be used as a resource, then the economy of this biogas, owning of biogas, will increase much higher, even at lower scale of farm level of biogas plant. I explained that how we have tested this different component is an experimental process that we did it, and this is an biogas plant we used for experimental purpose. Yes. Now next part, this is a very important findings we have found. Mostly in conventional systems, villagers use cow dung. However, in industrial plant where they have in other countries, they use different feedstocks, including the crops, corn or other crops, stems. But in Indian context, mostly at small scale household plant, this cow dung is used. But there are many residues, many your crop residues and other biomasses which could be favorably used for production of this biogas. But what are the challenges? Challenges is that this biogas, this microbes works on this biomasses if it have typical conditions. The conditions are determined in terms of their physical conditions, rheological conditions, because flow and other parameters are involved, its chemical characteristics, its sizes, all those things are there. Now, the co-digestion with any of them, with the cow dung, we have proved that it is useful. Its biogas productivity, that is biomethane potential increased. But we will have to ensure that whatever the feedstocks fed to a typical biogas plant, it should have the quality feedstocks. Feedstock means raw material that we use, that biomass. And then a simple random mixing is not going to benefit. We need some of this technology first, then second, the quality assessment by some tools, maybe some interventions that my colleague said and has already mentioned, some interventions where you could ensure that yes, this is the appropriate consistency that is required for this biogas plant. First, a technology for proper mixing, proper cutting, and then second, to ensure before feeding it to this plant. This is important, and that heterogeneity address could be addressed. We have seen by different type of microscopy of these materials, we found that yes, it has different level of the variations in their lignin content, variations of their other your cellulose and hemicellulose content, but a typical pre-treatment, through a typical pre-treatment, it is possible to make a consistent feedstock which could be suitable for biogas productions and thereby could maximize the biogas productions. Maximizing the biogas productions, economy will be in favor of these users. It requires some technology interventions where desert quality could be ensured. It is being taken care of this feedstock. Next, please. These photographs were done for this different type of things. Now, finally, out of this, whatever these things, I am saying that there are many other problems that biogas, though in numbers, there are many numbers. In numbers, if you find in statistics or in Government of India reporting or even reports of these schemes, you'll find the numbers are okay. This okay, but functioning biogas plants are very few. Even in it is not proper for me to quote for other states, or in Assam, you will find that you will find even biogas plant installed very recent 2010, 11, 12, 13. There are biogas plants which are not being operated. But you hear also biogas plants which are being operated for 30 years. This particular biogas farmers, he has 30 years old plant. But some biogas plants are not working. And there are many reasons. And then it is by the farmers or the users, they do not know what is the problem. Is it the problem in this biogas tank digester? It's a problem with the feedstock. It's a problem with the inside the digester. It's a problem with the gas holder. Is it the problem in this even this burner? Some of the burners blocked. Is it the problem with the pipe? The problem identification is a problem. The agency which install provide the training, but the training also they are handicapped. They did not know. So this is one issue that to be taken care of. Second, this quality aspect of this feedstock, quality aspect of the digester, this should also be known to them. And then feedstocks, and that there are many miscellaneous issues. Now we should try to have a solution, an app-based solution, smartphone-based solutions, where app itself will give, if he understands, if there are some sensors or some gadgets which will take care, which will understand. For example, already my group, I think colleague here, some of the colleagues with whom I'm working, we are conceptualizing that, we are thinking that if some sensors are put inside the digester, which could give us the conditions of the temperature, which could give us the condition of the gas pH conditions, which will give us this gas productions, different species of the gas, and then that information will indirectly give us then indications. Same way, the doctor gets the some indications of my stomach conditions, whether I need to take a tablet for gas or I did not. The same thing could be that your diagnostic is possible by some sensors. And then automatically maybe some control, there is also an ambitious plan could be done, that if a temperature sensor, temperature is going down because it works with temperature of 30 degrees, temperature is now 25, some arrangement of thermal energy management is also possible, automatically taken care, or we can have some manual control. Similarly, pH can also be controlled, mixing can also be controlled. These are the interventions required so that a smart biogas reactor could be taken, will take care of its own problem, and then it's a luxury for the users rather than a headache for the users. I have just given a visual here, connecting that in mobile apps itself could give the solutions to all of them. And then these mobile apps can be an repair, maintenance, or service provider business. Some of these entrepreneurs could come for doing this business. Next, please. I'm really happy to introduce two of my colleagues, Akshay and Abhishek. I have been visiting. This is an bio-CNG production plant in Punjab, near Chandigarh. And we are working, collaborating with them now. They are now struggling and they are doing good business, but they feel also the similar thing. Earlier, whatever the presentations I have given so far was considering this household small-scale biogas plant. But biogas can also go to this industrial scale, they have proved. They use it with different feedstocks, and then there are also problems. The profitability could be enhanced if some technological interventions could be introduced over here. And they are producing gas as well as organic fertilizers, and more or less they are here. Maybe some of this direct input we could get from them. And then technological interventions in terms of the sensors, in terms of these automations, in terms of this data transfer can improve their functioning and then increase this business better. Next, please. We could say that, just to conclude here, this residue which remains unutilized, which is the methane, because it is unutilized means after fulfilling the organic carbon requirement of the soil, whatever is left in the field, this is, even if it is not burned, it could create lots of problem of greenhouse gas emissions. Under the rainfall conditions, and when it goes anaerobic, then it will produce, and there is a lost methane, and this global warming potentials of methane is much higher than its carbon dioxide. So it is a very urgent issue to address it. And then we found that in India, around 200, safely say that 200 million ton of this crop residue could be easily used out of the 686 million tons of the 28 states. We made an assessment survey all over this India through these different parameters available on these crop productions. And then bioenergy, finished, last slide.
Yeah, fine. Yeah, okay.
It's going to be, I think, last slide. Next, please. Next, please. And this is concept I actually prepared to give, that multi-crop residue is an issue. We can take care of these different characteristics of different residues. There is an challenge now, but technological interventions can convert them challenge, and then that could be a resource. Multiple crop residue also address the issues of availability at different seasons. We can have the different one, we can take care of this issue. We have some pre-treatment technology, and then again quality ensuring technology, and then finally some of this technology intervene. I have shown, I don't know whether it is proper or not, some of the technology intervenes biogas plant, and finally all will be taken care by this your technology, what Chide and other groups members are telling now. And finally here also some ambitious plan of us that this biogas, if we need to a bottle transportable CNG, then carbon dioxide to be separated, and then fertilizer to be separated. So we'll have 3 products, and dry ice, carbon dioxide, the biofertilizers, and bio CNG. And if this goes with us, and another thing, although I mentioned the reactor itself, There are different reactors now coming at different level. Your plastic reactors, reinforced reactors. Yes, reactor design is also some gap is there. There is also possibility of some interventions, technological interventions. The smart reactor as good as a washing machine. Why I need to rely on all those problems by your masons, then difficulties. There are many practical or engineering difficulties of then good reactors. So maybe material science improvement and that our desired requirement could lead to an development of a good reactor as good as a washing machine, as good as our refrigerator. That could be possible. That's a dream over here. So with this, I thank you all. This is, I think, last slide. Please, next, please. Thank you.
Thank you. Thank you, Dr. Baruah. It was very interesting topic on biogas, which I have not worked in biogas much, but I think where you can apply for technology, what you're saying makes some sense. Like you took us from a village to a big commercial production level, it needs technology. That's what we understand from your talk. Now, I will put on the floor for any question and answer anybody has. You can raise the hand because I cannot see all of the people on the screen. You can raise the hand. If you're, you can put on the, Dr. Narendra first raise the hand. I can see him. So can you ask the question, please?
Yeah, Dr. Baruah, two sort of issues that I would like to having seen some 5 years back in Maharashtra, for example, at two places they had put some 8-meter cube biogas digesters, and one had to stop because there was no adequate water. So if we can develop a technology where, for example, half the requirement of the gas, like water, for example, 1 kilogram of tongue requires 1 liter of water. If there can be some process, biochemical process by which you have a dry fermentation, that is one question. And second, biogas digester just completely failed because there was no adequate dung. So what the recommendation came was like, install a food processing or a fruit processing plant next to the biogas digester. So it becomes very, very, suggestions or recommendations from the committees that, you have a biogas digester, now you bring a fruit processing or food processing plant. So these two comments, if you can kindly address.
Thank you. Shall I respond it very quickly?
Yeah, please. You have to.
Very quickly, I'm responding. Yes, in fact, these problems are visualized while preparing these presentations. One is that water requirement. What we said that separation of this water, and then this water could be now presently in conventional systems, it is being not used. But if we could separate these waters, it is recirculated, this is become more effective because it contains enough. Then additional requirement of water will be much reduced, number one. Number two, there are now technologies of dry decomposition or dry degradations, and where water requirement is much lesser. In next questions, we should not, it is very difficult to rely only a single feedstock like cow dung. That's how I am saying, I'm advocating here in my presentations, the multi-crop residue or any organic matters, for that matter, which is suitable. And then these technological interventions could help me to convert any damn matters which is decomposable to convert into an suitable feedstocks for raw materials for biogas plant. Thank you, sir.
Thank you. I want to call on Mohanty. Mr. Mohanty, you have a question? You raised your hand. Can you ask your question now? Mr. Mohanty? Setu, can you enable other 3 people also? Mr. Vengaya, can you ask your question, please? You have to unmute yourself. Mr. Vengaya. Mr. Mukesh Kumar, you can ask your question. You can unmute yourself. Naresh Prasad Singh, you can unmute yourself, ask your question. Any of the 4? If you can hear me, you can unmute. All of you allowed to talk.
Eji Baba. Ajay.
What?
Abba.
Hello, sir.
Who is
I am
that?
audible. Kumar, sir.
Who is that, please?
Hello.
Hello. Speak.
Mukesh Kumar. I am audible.
One person. Mukesh.
Sir,
First speak, Mukesh.
Yes,
Others
sir.
don't speak. Mukesh, you speak first. Mukesh first.
Yes, sir. Thank you, sir. I am about biogas production in home level for how much price and first time and place required for first time allotted biogas production at home level, sir.
Can I speak?
Yeah, please.
This is Lalit Maheshwari from Bombay. Bharat Kisan Sangh had done at Rajkot bottling plant for biogas, and even Kanpur Gausala tried bottling the biogas to supply across. So somebody should be able to share all the information across happening in the country. Maybe we can make it viable.
Good. Thank you. Mahendra Kumar. Naresh Prasad. Okay. Now I have. Okay. Anybody? Naresh Prasad, you want to speak? Okay. Setu, block all of them. Robesh Maiti, you have a question? You can ask.
So, Dr. Baruah, you said that some of the places the plants are not working. So it's purely the technology or the commercial viability. So question is not about asking that question. Question is, what is, can you give some picture about the finances and commercial viability very briefly, you know, how the input costs are and how it is charged?
Yeah. Those your failure cases I am quoting, I mean mentioning about this rural the plants which were installed under the schemes, different schemes of the rural development, different schemes of the government of India's forest department schemes or government of India schemes. And now here around 2 meter cube plant costing around 30,000, and then there are provision of subsidy, there are provisions of subsidies for material subsidy and these things. I think eco-financial is one issue. If it is given by that your government sides, then there is no issue, they could do it, and even they need it. But here, after providing this financial support, then also it is failed. The failures are from our study, I have at least surveyed around 60 plants. The failure reasons are different. Sometimes the civil engineering failure, sometimes the biological failures, and some of the neglected attitude, anything they put it in this your biogas plant. And then understanding well that this is a biological system. So these are different type of failures. Yes. As far as the financial viability is concerned, my friends Akshay and Abhishek is there. They could quote even the colleague saying about this Gujarat case. Yes, financially it is much viable. There are provisions of subsidies also under MN area also. If we compare the unsubsidized LPG, and then we consider the other cases of remoteness also, it's obviously viable. And then Akshay and Abhishek, their source facility and then BioCity that plant in Panchkula has proved. I have even seen their plant. It is much viable. Abhishek is here. I think I request Abhishek to just answer these questions. It will be better from to Abhishek.
No, I think we should because questions are time is very short. I think we'll have it for the next session. We have the
Thank you.
They can ask the question.
Thank you.
I think I would next. We have one more. Yeah, 1 second. Indramani wants to speak something, please, Dr. Indramani.
Dr. Baruah. Dr. Baruah.
Yes, please.
The aim of this seminar is to find out technological gaps, because in one of the slides you mentioned.
Sorry, sound is not coming.
Not coming.
Okay, I will.
No, it's coming.
Many we are able to hear you. I am able to hear you well.
Okay. My submission is that objective of this webinar is to find out.
Audible. It's not audible.
What you said.
Okay. I will.
We can hear Dr. Indramani very well.
Okay, I think we'll stop there. I think I understood Dr. Indramani. I will come back to that topic from Baruah when he can speak.
So he mentioned about gaps, and that gap should come out in this webinar, that what should be done to make this viable and what we should do to make it to spread. So these are two things which we wanted.
Okay. We'll come back to that. When another discussion is there, that time we'll come back again to him. Baruah will come back again. Now, very short, I will, because I want to show the flow of the whole thing, the webinar. Today we are running short, but then we'll go another 10 minutes more afterwards. Please forgive me today. But then still we are running short. So I want to show how the flow will be there for the next webinars also. Okay. So we'll have one session, short session called Know the Team. Because here we have opportunity. For example, today people know about Baruah is working. Others we don't know. Everybody cannot be seen. So we taught it short. So 2 to 3 minutes. Another 3 persons here, I want them to introduce themselves, what they're doing. Time is given is 2 minutes to 3 minutes. Okay, I think Murthy, Dr. Murthy. Dr. Murthy?
Yes, I'm here.
Yeah.
So,
you can put your,
good evening, everyone. And my name is Ganti Murthy. I'm a professor here at IIT Indore. And the research areas that I have been working on are primarily focused on resilient agroecological systems. So essentially, I work all the way from the soil health to the food processing, and we work on a lot of systems analysis part. So we take a systems approach and to these systems. So we look at technical feasibility, economic viability, resource sustainability, environmentally impacts of different technologies and processes. And we have primarily worked on biofuels and bioproducts for a long time. And now we are moving into wastewater treatment technologies. And we have used IoT technologies. We have used a lot of sensors, development of sensors, and very advanced process control, so that we take the complexity of some of these processes, for example, the biogas digestion or the fermentation processes, and then shift them into these control systems so that the actual implementation of the controllers themselves are very simple. So that's what we have been trying to do, and then we have actually commercialized those products. And for example, a fermentation process control, we have commercialized that. We have developed a technology for treating the landfill leachate, where we actually recover metals and things like that. And before coming to IIT Indore, I was a professor at Oregon State University. Thank you.
Oh, thank you very much. Next, I would like to invite Dr. Narendra Shah. Please, can you tell something about yourself?
So this is particularly for our young friends. I want to sort of, in a given 3 minutes, I want to tell you a story about self. So as a young lad of 21 years old, I actually with a BTech degree in agricultural engineering, I landed at AIT Bangkok to do my master's. And post my MTech at AIT Bangkok, I worked in energy department at AIT for about 4 years. And but then I embarked on a PhD program in process engineering in France. And post PhD, I had a brief stint as a postdoc fellow with EEC ASEAN project on small scale energy generation in France. And after that brief stint as a postdoc, I returned back to, joined a Center for Technology Alternatives of Rural Areas at IIT Bombay. And I'm still there. I'm stuck at IIT Bombay. I teach there and research in the areas of agro-industry, decentralized small-scale energy technology, and food processing and nutrition. If time allows, I will try to prepare some talk as indicated by Dr. Syed on how sort of small scale energy, for example, how we can use it beneficially in value addition in food and nutrition. And currently, actually, I am posted in AIT Bangkok as a visiting professor here. Thank you. I hope I finished my story in 3 minutes.
Yeah, I would like to now invite Dr. Hazarika, MK Hazarika. Dr. Hazarika, please.
Good evening to all. So I am Manoj Kumar Hazarika, professor and former head from the Department of Food Engineering and Technology, Tezpur University. Presently heading the Center of Innovation, Incubation and Entrepreneurship. and also jointly coordinating the Technology Enabling Center of the university. Of course, I started my career in Department of Agricultural Engineering to begin with at Neris, Karnataka, followed by a Department of Agricultural Engineering at Assam University, Silchar. Of course, actually as an engineer, actually I find myself to be more of a what we can call as an integrator. Actually, some of my activities are jointly conducted with people from computer science or electronics or mechanical engineering or molecular biology. So at my personal level, actually, I am working on post-harvest handling of rice or food grains and means fruit and vegetable of this region. And of course, to join this PAZ, actually, I was quite, it is a coincidence for me. Actually, I have been discussing this thing actually at our department because my affiliation is for food engineering department, and where the nutrition concept is quite talked about. But actually, what is coming up late is actually sustainable nutrition. Means actually where we should talk about means the nexus of food, energy, water, and overall sustainability. So actually that way, when actually I got to know about this initiative, so I am to be very interested for this one. And of course, overall goal actually what I think that actually we should work for a larger goal like the food solution for the global population that may be coming in by 2050. Also, we can have a target. But actually, at the same time, actually, I was just seeing for agricultural engineering or in general for any classical engineering, that engineering knowledge system that actually would be, that is what is called a system approach that is being employed by this data science, where actually they see as a cause and effect in the form of more of a black box. So that may make actually for the students or for upcoming students that actually that engineering knowledge may not be that preferred, may not be of that preference typically for this, because actually it will be requiring lots of mathematical considerations, design considerations, all. However, actually if you consider this innovative prospect, actually the understanding the engineering units as smaller units will be adding to the innovation for future technologies. So actually presently I am working on that aspect, that is actually integrating data science perspective, something actually I'm learning data science, but at the same time actually I'm trying to do whatever is the classical or physics based engineering based models and then integrating them. Actually that is a concept that has been done what is called as a gray box model. And of course, in general, actually, I find myself associated to basically competency-based design of content and delivery of engineering and vocational education. And of course, I look forward for this series for effective deliberation, and where actually we can fulfill the concern of the masses. And of course, here actually another aspect in respect to actually agriculture engineering, I should say that actually we have it as an advantage or as a challenge as well, that actually one of our stakeholders is always a farmer, actually who do not like to take this farming practice as an enterprise. So therefore, actually much of our innovation is motivated by sometimes these government policies. So therefore, actually we are not sure whether actually our innovation finally actually yields the benefit or means overall goal, meets the overall goal. And for our locational advantage, we have found that actually this one of the enterprises which work on in this line is basically tea industries. So probably that can be a good case study where actually we can say that actually agricultural engineering can give them a wholesome solution to them, and probably that can be beginning point. Of course, in that actually there has been some limitation that actually how they are opening up to us and all. But actually now we are at this university, we are starting that whether we can just go along with them and find some solutions, and that will be model for overall agricultural engineering based enterprise. Thank you.
Thank you. Thank you, Dr. Hazarika. I think next time, this is the first time we are trying this. Next time, I think I would like know the team people will tell about skill sets, what they have probably. Today we are running short of time. What skills they have so others will know. For example, I know one of the persons knows C very well in the team of 3 out of the 3. C is excellent, he knows. So I think when you make the tag team, I think he can probably guide and mentor the people in that particular technical skills, because some people have technical skills in different areas. So I think next time we'll do that. But right now I'll show you another part for a few minutes only, short. What is exactly the idea of this? Actually, today I'm going to take only 3 minutes on this, but it's going to be half an hour from the next one, 20 minutes, 25 minutes. I'm going to show after this presenter what the tag is going to discuss about it. Can you please put a slide, please? Today it will be delayed by another 5 minutes. I think let us bear with it today for special case. Now, for example, this is the slide we have seen, which Dr. Baruah has shown. So now it looks simple. I think one thing we got reply, biogas, it is financially viable. That we come to know from him. This I asked also very first before came, is it financially viable or not? Then I asked him, what is the reason you're looking for technology here? And we had a webinar. I had a webinar with him, with team also, Dr. Baruah's team completely. He's a Department of Electronics people, everything about a team. Now the question is, he says, the problem is actually, there could be a problem of pH value. It may be acidic. So the people say, farmer says it's not working. That's all. So how to find out? So then we discuss about, I think this is a challenge actually. If you want to use it, because we don't use much sensors. The very first you see here, we will come back with the solutions of sensors, how to detect the gases. For example, he told already methane and CO2, this is the two available, and different type of sensors available. So our team will help to identify the sensors, and somebody has to test it. The whole thing is somebody has to test. Only one lab can test this particular sensor is useful for this, and it's enough for throughout India. We can use all this information. That is the idea of this tag team, what I'm thinking. For example, you have hydrogen also, alcohol, CO and methane sensors are very cheaply available sensors. So sensors is one thing. Then he's talking about another one sensor also, flow measurement sensor. Flow measurement sensor or mass volume measurement sensor also we have to identify. Flow means how much is going to put inside and how much gas comes outside. And he needs a switch to find out whether gas is flowing through a burner or not, for example. So the complete sensors, then as you see the picture, it's in the form. So you have sensor in different places. So you have to know how to network locally first. Okay. He says the temperature, the person standing on the top of the slide, you see optimum temperature under varying seasons. So you need a temperature sensor there somewhere, and that must communicate to some other place near the burner. So this whole networking, local networking is excellent topic for this. And plus you have next level, the data goes to server back again. So there again, the third level. So actually when you see the application, a lot of learning can be done in technology which comes. So we will discuss this in next session and all. We'll discuss in detail about this. Right now I stop with this in short of time, but I think next time we will take up this. We'll come and present to you for this particular case also, probably after a few weeks when we make some models and something like that. We'll come and explain to you how we have solved this problem of this technology we come. Now with these words, I would like to request some remarks from Professor Gajen Singh. If he can tell some words. Slide off, please. Setu. Professor Gajen Singh. Professor Gajen Singh is there? I think he's there.
Yeah.
We would like to have your comments and advice.
Well, I must congratulate Devin Baruah for excellent presentation. My understanding of biogas, whatever I have followed, is that on the individual farmer units, for one reason or another, not technology regions, but mostly management region, feeding every day, cleaning up from time to time, taking out the way, that has been a problem. Can we develop an entrepreneur system, enterprise, which will work more as a community, serve a community rather than an individual unit, and provide like as a service provider, giving a pipe connection to some 20 houses or 30 houses or 40 houses, okay? Then this entrepreneur can collect the raw material. It's not a problem to get. Raw material is not a problem in village from cow dung and all that. Question is how to manage it. So I think if we can develop a simple project of coming out with different sizes of biogas plants to serve a small group, 20 families, 30 families, 50 families, whatever it is, I think that could be a very good start. I do not see a much future for individual units for an individual family. I think it's too much lack of attendance for few days. They go and visit go to a marriage party in a relatives, 4 days something, everything choked, dried up, and nobody wants to start. There are so many other things. Winter season is different problem. Summer has a water problem. So I think the neglect for one aspect results into complete failure of that system. So my suggestion will be to work as an enterprise, as a custom hiring type system, service provider type. And if somebody, Dr. Baruah and other IIT Delhi and CIA Bhopal, there's so many places where they, and IRI Indramani's group himself is very familiar with the villages and working with it. Come out with those models. So my suggestion will be look at those workable models. Thank you.
Thank you. Thank you. Actually, now I have a request to make to all of you. We were for making a webinar successful, we require challenges. So we require challenges. You're facing challenges in every area, but it must be brought to us. Like one of the examples he told, because we are searching for examples, people who have to give us technical challenges, like I told you, only then we can help. Because I know a lot of areas in water everywhere can be used. We have talked about it in different forums already. I want really people who are working on the particular areas. For example, this is energy. Now we have problems with solar pumping. I know very well. The solar pumping is a big problem. There's no data coming inside. It can help very much technology. So anybody working in solar pumping, for example, can come inside. Last time we had an example of solar refrigeration used. Dr. Indramani, one of the team members showed that. So I want energy, that type of technology, what requirement is there, where they need our help or where the entrepreneurship can come into picture. Now, like I told you, next theme also I'll give you. Next topic is, we are talking about, I have given one theme topic, that is the myth and the truth. This will be one of the theme where you can give me the speaker's topic. What is the real myth? What is the real truth in different type of, in agriculture, what we are using, starting from drones, starting from whatever application, how we can streamline, so how the people think now, how really can be implemented the technology. So this we have one more thing, energy we have theme now we told, energy, anybody wants to talk on energy, water is water you can take, water generally I'm calling, very important, the water problem is very important. Why I'm saying technology is important is, I know some projects which are happening, again I'm repeating, happening even in Maharashtra, where we want to find out what are the intervention done by different projects, different stakeholders, in water, in contour farming, everything. It cannot be validated by now. So we need the system to come up with picture, people to understand. So with this request, I request all of you to give support. So we will take care of the training and finding solutions. The good team will make, and we want more people to come in the tag team. Anybody else want to have suggestions? We will have, we can talk for another few moments. No problem. Yes. You raise your hand. Yes. Anybody can give it. Tell your name, please.
Just may on I thank you. Already we are taking project of community biogas plant Tezpur, 3rd households now going forward. 2 used, and I request that if come together and help us. There are some issues I have not covered in this presentation. And this is through a DST seed sponsored program in a remote village. And hopefully this will work and give us more information how to go with this model of community biogas plants. Thank you, sir.
Thank you. Thank you. Anybody else? Anybody else has suggestions? other topics or how to get the other new topics? Anybody new topic suggest? Any theme you suggest? Anybody?
Excuse me, sir.
Yeah, please go ahead. Please go ahead.
Excuse me, sir. Am I audible?
Yeah, yeah.
Sir, my question is from biogas plant, so much of slurry is available. And in drip irrigation system, we are talking about fertigation. And also we are talking about organic farming. So we should develop some methodology so that this slurry can be used as fertigation and drip. So this is a future research, a tremendous scope is there with the biogas, with a link to drip fertigation. So this is my suggestion, but research has not been done, but this is a scope for future. Thank you, sir.
Excellent. Thank you. Excellent suggestion. I think anybody else want to comment? We have another 3 minutes. Anybody can comment. Anybody has suggestions? No problem. You can talk.
So I tend, Rubesh here, I tend to agree with Dr. Gajendra, that, so of course this group is trying to find a technology solution. So even if we provide, the whole system will not probably be successful there ultimately, because there are other elements. So I think this problem needs to be defined, called as an efficiency. And today it is an efficient overall modular efficient. And then we say when we put technology, so today it is running at 20%. And when we do provide a technology intervention, because there will be cost, but the efficiencies will go to 80 to 90% overall system, then probably one can make a sort of entrepreneurial model which attracts people, So, and also is a return for all the efforts and the cost that will be associated with the technology.
Okay. Thank you, Rubesh.
Thank you, Rubesh.
Can I come in? This is Naren Shah here.
Yeah, please.
Yeah. So, the Ministry of Petroleum had come out with a scheme called Scheme Ujjwala, for example, by which, it had good and bad points. Like it did sort of give the subsidized LPG cylinders even in forests, for example. So, see the flame that comes out of the biogas, which is as good or even as better as the LPG flame. So if for example, as a part of some 10% of the scheme Ujjwala can be diverted to biogas, I think it could make much more impact in terms of increasing its utilization in the village areas. So somebody will have to sort of make this as entrepreneur, or somebody will have to take up and say that it works as good as LPGs. So let the 10% of the users which are sort of target beneficiaries of Ujjwala scheme, let them use the biogas, mostly the rural areas.
Thank you. Dr. Indramani?
Oh, I just wanted to add that this is really a very important area still. And what Professor Singh said, that rather than at individual level, we should go at a decentralized but connected one. Farm where we can provide energy solution to, let's say, a village, a complete village, we can provide energy solution. The second thing I wanted to add, that is byproduct, this biogas slurry has a lot of importance, which my colleague told, and the research has been done on application part. Apart from increasing nutrient of the soil, it increases water holding capacity, and if you apply biogas slurry, you can reduce one irrigation. At least in major crop like wheat and others, you can decrease one irrigation, reduce one irrigation. So that will be other. So that byproduct has not been basically used or popularized to the extent it should be done. So these are the gaps which we will enlist, that with respect to biogas, this slurry utilization in fertigation, particularly how it can be used in fertigation. Then what should be the commercial viable, proportion of biogas production. Professor Singh knows that we got a very big project. There was some problem. Otherwise, we had a, through Japanese support, we had a proposal. It was approved, but finally it could not basically materialize. Whole area, we had a plan to find out energy solution. So saying the energy crisis, biogas stands a very good, it has to play a very good role, but all the technological hiccups and commercial and your business model, that all needs to be developed to make biogas a very important energy source. With this, I thank Dr. Baruah for a very wonderful talk. And I'm really very happy, as Dr. Syed mentioned in the beginning, that Northeast, West, North and South, and whole India is together.
Plus US and Bangkok.
And Bangkok.
I'm in New York.
And
I'm very far away.
So this is what is another purpose of connecting people. And sir, we missed that one. We have many successful stories as one of our farmer friends shared, that in Gujarat or in other parts where successful stories are there with at farmers level. At least one objective of this webinar will be to collect all these information at one place and find out what all is available at this country, in particularly in biogas area. So that again we will say, and I will request my farmer friends and whosoever are participating, please share the information little in detail so that we can compile that and put up at our ISA website that what all is available in biogas area, research level, commercial utilization level, and then gaps, etc. We can collect all this information and put it at our website. That is what our peer group has been suggesting, that bring in all these technology at one place, so that with one click a person can see what is available and what are the gaps. With this, from my side, I thank you all, and Professor Singh and today's speaker, and Dr. Syed, you have been part of the whole program. So, lot many thanks, and all Partha and Setu, Rauf and Dilip and all are working. Thank you very much for all your contribution. Thank you.
Thank you.
Thank you.
Setu, we close down. Thank you. We close.